Hello all, Mr. Havel again. Today we're going to go over chapter 1.5, which is parent functions and transformations. Okay, so both of these with linear and absolute value graphs. So a parent function here is the most basic graph that we can have for whatever function we're talking about. Okay, so without any transformations, moving it left to right, up or down, any of that kind of stuff. So we're going to start out by taking each one of these x's and plugging it into our parent function, right? So if I have an x of -2, I plug it in, I have the absolute value of -2, which comes out to be just +2. Remember, absolute value is just a distance, so how far away from 0 is it? It's just 2 units away. So my coordinate would be -2, 2. Now, if I plug in -1, comes out absolute value as +1. And so my coordinate is -1, 1. 0 comes back as 0. 1 comes back as 1. 2 comes back as 2. So we have 1, 1, 2, 2. Cool. And so we're just going to plot that. So we have -2, 2, -1, 1, 0, 0. Sorry, everything's shifting down, so get it while you can. And so then from here, we know absolute value looks like a V graph. It's V, or if it's negative, it's upside down, and it looks like that. Okay? And so we shoot off here from our vertex and shoot up in both directions and make our Y. Okay? I'm sorry, this thing keeps moving. It won't stop. So a couple of the highlights is this guy, before it moved a bunch, this guy is called our vertex, the one at the bottom. So that positions at 0, 0. Our axis of symmetry is where would if I folded this guy in half, so I'm going to do a pretend pink line here. If I folded it in half, it lands on itself. Okay, so that would be an X. Since it cuts through, we get a little confused. Yes, it's in the Y direction, going up and down, but it cuts through the X-axis. So it cuts through at X is equal to 0. So that's what our axis of symmetry would be. And then set notation, this is what we went through a few classes ago. So if you're struggling on that, go back and watch the video on domain and range. So set notation, this is, remember, with our squigglies here, x such that something, okay? And our range, y such that something, right? So that something here, if you notice our domain, it shoots off into the left direction. So what I like to think about is this guy goes to the left and up forever. This guy goes to the right and up forever. So domain-wise, all of our x's are covered because they shoot off to the left and right. So we can say x is all real numbers with our fancy r there. Cool. Now y shoots up forever on both of these, right? It shoots up, but it doesn't shoot down forever. So our starting point, again, before it moved, was right up here at 0. So it's 0, and then it's everything above 0. That's what our y values are at. So I could say y is greater than or equal to 0 because we have a closed circle there. Now, interval notation, this one is, we're saying the same exact thing, but just in a different notation. So the way we'd say this is we'd say -infinity to +infinity. That's how we would say all reals. And now our range, it starts at 0 with a closed bracket because it's a closed circle, and then it goes up to +infinity because going up in the y is positive. So it goes up to +infinity with the parentheses because it's got, we can't reach infinity. So infinity will always have those parentheses on. Okay, now it says here, graph the absolute value function in a graphing calculator. State how the graph is transformed from the parent function. So remember this parent function, keep that in your head. It starts at 0 and shoots off. Right, so I'll go through, you'll do, ask your teacher for a graphing calculator and you can practice this when you're in class. So I'll go through this super quick. So if I was to put this in a graphing calculator, you're going to find out that it comes up here. And it looks something like that. Okay. Whereas number 2, you'll notice here, it's going to look something like this. Right? So you should notice something. What happens when there's a number outside of the absolute value? Right? What happens there? Now our next idea is, well, what happens here? Right? So it's inside the absolute value. So we would think -3, right? But it's a little bit tricky on the inside. This one actually comes to the right 3. And this one, again, our first thought would be to come to the right 1, but it actually is opposite of what we would initially think. So there's those two, right? So what can you tell me if the number is inside of the absolute value? You should be able to tell me kind of two special things about that, okay? Now, if it's the number is out in front, right, we have 0, 0 as our starting point because we don't have anything inside or after. But now the trick is it gets pretty skinny. Oops, that was a bad graph. So it gets pretty skinny there. Okay, and then our last one here, similar to this, I guess second to last, is we still have 0, 0, but now this guy goes like this. And this guy gets a little bit wider. And our last one, we have a negative here out in front, so that actually goes like this. Okay. So I did them all in different colors on purpose, right? So this is what we call our absolute value in vertex form. Sometimes you'll hear it in HK form. Okay, so those two mean the same thing. So a few of our highlights here is A does two things, right? So if A is, I'll say if A is greater than 1, absolute value of A is greater than 1, then we stretch it. Okay, stretched vertically. Cool. And the best way I can describe that is if you were to grab on, pretend like these are my hands here, and you grabbed onto both hands, and you pulled me, my hands would get closer and closer, right? So I'd get pulled together. Whereas if A is, absolute value of A is between 0 and 1, okay, so like 1/2 or 1/3 or 0.4, anything like that, this is what we call compressed. And that's vertically as well, okay? So that's going to be compressed, and that's something like number 6 here. So number 6 is compressed. It's a lot wider. So it's like if you push on my hands and I keep my arms straight, my arms are going to go out wider, right? And so another one that's kind of related to A here is if we have a negative A, right? That guy flips it over, and we call that reflected. Oops, reflected. And so all that does is flip it over. Cool. All of these, when we're talking about absolute value, our A value is purely going to be the slope. That only works when we're talking about lines and absolute values. When we get a little bit further on into the chapters, you'll see that unfortunately that A doesn't work as a slope anymore. Okay, so our next one here, I'll go back to my pink. So that is your, actually I'll do green next just to keep them in order. So is your H value, okay? So our H value, notice that it's X minus H. So that causes us a little bit of problems. And so our H value moves us left or right. Right, so moves the entire graph left or right. And so what I always say is opposite H. Okay, and the reason being is whatever H is because of this negative sign. So if I plug in, for example, here, my H would end up being +3 because if I put +3 here, I get X minus 3. If I said my H was actually -3, I'd get X minus -3, which would change it to a positive. So that's why here my h value is -1. So because I had to do x minus -1 in order to get that plus. Okay, and so our last one here is in the pink, and this is like the first two examples, and this is our k value, and this moves up and down. Okay, moves the entire graph up and down, and the way I always say it is keep k. Opposite h, keep k. If you're in my class, you'll hear that a million times. Cool. So here's a few different forms. Okay, so if you notice, please pay attention. Linear, right? So we're just talking about a line. So if you notice the difference between this equation right here and this equation right here is, for a line, we have parentheses. For a vertex absolute value, we have these straight bars. Okay, so we have the straight bars on those. So slope-intercept form, you should be pretty comfortable with this. You saw this a bunch in Algebra 1. Y equals mx plus b, where m is the slope and b is the y-intercept. Okay, we'll use that quite a bit. Now here, this is what, again, HK form, you'll hear it vertex form, that kind of stuff. And so on this, A is only on this guy, is A the slope. And here, sorry, I don't know why it's jumping around. HK is a point on the line. Okay, so for a line, HK is a point on the line. For the absolute value, HK is our vertex. Cool. So as you're going through this, be super aware of, do you have parentheses or do you have those bars? Okay, so if you look, our point would be opposite h, so that's my h, so opposite h, so 3, keep the k, so -1. So that's just a point on our graph. And then from here, we take this value, which is our a, and that's our slope. So from this point, we rise to run 1, right? Because we can make this as a fraction, 2/1, and connect the dots. That's our line like that. Okay. We have parentheses here. So to get our first point, we do opposite h, so -4, keep the k, 2. So -4, 2. And then our slope, this is our a value. So slope is now fall to run 3. Fall to run 3. Okay, notice how I didn't go to the left. The negative tells me to fall first instead of rise, but it's always to the right. Okay, so you're going to either rise and go to the right or fall and go to the right. Okay, so here's the parent function for each one. Notice for a line, it's just x. For an absolute value, we have the bars around the x. Okay, you'll see it always like this, but remember, it's not wrong if you have the parentheses like this. So you'll see whenever it's an HK, you'll see parentheses like this. If it's not an HK, well, this is still technically an HK, but if it doesn't have an H and a K, then you're not going to see the parentheses. Okay, so here's all the stuff that we already talked about. Changes in slope, if it's stretched or compressed, right? So we already filled this out up here. On page 11. So if it's stretched or compressed, reflected, the H, and the K. Okay? Please get super familiar, comfortable with all of these. We're going to use them all year. Okay? And we'll use that. You will use the idea of them all year for different graphs. So on the rest of these guys, right, it says graph and then do all the information. So my recommendation for you is first find the vertex. Okay. First pay attention, is it a lot? What kind of graph is it? So it's got the bars, so we know it's absolute value. So this will be one of those V looking guys. So grab the vertex, right? So my vertex is opposite h. The h is always going to be inside the absolute value or inside the parentheses or inside. It's always the inside one. So inside, and then k, there's nothing out there, right? So that guy is 0. So h and k can be 0, but here my a value cannot be 0, right? If I have a, then it has kind of has the variable go away, which we don't really want. So a is kind of like if you imagine just a straight up x, right? What is the number out in front of here? Well, it's a 1, right? So my a value here is 1. So that on these graphs is my slope. Okay, so my vertex is at 2, 0, so I come out 2, 0, and my slope is 1. So since I know this is an absolute value, I'm going to do a slope of 1, so rise 1, run 1, and I'm going to reflect that over my axis of symmetry. So I'll reflect it over to this other side, and there you go. That's my first graph. Okay, the parent function it's just asking, is this a line or absolute value? Well, this guy's our absolute value, so it has the bars. Our transformations, okay, so what I always tell my students is just look at A, H, and K, right? So our A is 1, so we didn't do anything. We didn't stretch him, we didn't compress him, we didn't reflect him or anything like that. The only thing is I had an H value, right? And so what I do is I say, how do I get to my vertex? Give me directions on how to get here, right? And so we went to the right 2. That's it. We didn't go up or down or anything like that. So that's all we did. Now the domain, we'll get more and more comfortable with this. Your teacher might have you put it in set or interval notation, but right now we can just show it as domain is all reals. Okay. The reason it's all real numbers is it shoots off to the left and shoots off to the right forever. Now our range starts at 0 in the y and then goes up forever. So y is greater than or equal to 0. Cool. Let's do a few more examples here. Vertex here. So opposite h, keep the k. So opposite h, keep the k. That's my vertex. 1, 2, 3, 4, 1, 2, 3. My a value again is just 1. So it's a 1 out in front of there. So rise 1, run 1, reflect it over. There's my graph. Okay, parent function, this is still absolute value. That's all it's asking. Now transformations, my a value is 1. Okay, so since my a value is 1, I don't do anything. The only time you do something for stretch, compress, reflected, again, is if a is anything but 1. Okay? So transformations, how do I get to my vertex? Well, I had to go to the right 4, and I go up 3. So that's my transformations from this graph. Okay, how did it change from our parent function? Domain, hopefully you're kind of getting the feel for this. It's all reals, because it goes left and right forever. And now for my range, this one's a little bit tricky. It's going from here and going up, right? So my range is y is greater than or equal to 3. Cool. Now 12 looks a little bit different, right? I still start with my vertex, so opposite h, keep the k. So -1, 1, 2, 3, 4, 5, -5. But now my a is equal to 2, right? So that's my a is my slope, 1, 2, 1. So go rise 2, run 1, and then reflect it over to the other side. And so that stretched my graph. It made it, that made it a lot tighter, right? So still absolute value. My transformations, well, how do I get to my vertex? I had to go left 1 and down 5, right? And then here, since my a is something besides 1, I can go back to page 11 if I forgot, but if a is greater than 1, remember it's stretched by 2, by a factor of 2. Your domain goes left and right forever, so it's all reals. Your range is going up, so it's greater than or equal to this point right here, the bottom of your graph. So that would be at -5. Cool. And you should kind of notice with your range here, right, with your absolute value, they're very closely related to the y of your vertex. Okay. So now 13 and 14, the hardest part about 13 and 14 is just make sure that you're paying attention, right? So on these two, pay attention. Right? So we no longer are doing absolute value. Both of these parent functions are just a line. Okay, so we do the same idea, but we have a point, so opposite h. So 2, -1, opposite h, keep the k. So 2, -1, we have it right now, but now my a is equal to -1, and that's still my slope. So I drop 1, run 1, and now if this was absolute value, I'd reflect it to this other side right here, but it's not. It's just a line, right? So once I have 2 points, I'm done. I can just connect those 2 points and make it a line. Okay, so transformations, you're still going to have the same idea for the transformations. How did I get to this point? Well, I had to go right 2 and down 1. Cool. And now, is my a anything besides just straight up 1? It is, right? It's -1. So negative, look back on page 11. If it's negative, then it's reflected. Okay, it's flipped over. Now the nice thing with the line is if I break each endpoint down in 2 dimensions, this goes to the right and down forever, and this one goes to the left and up forever. Okay, so my domain are my x values. So does it go to the left and right forever? It does. So all of my x's are covered. Now for my range, does it go down forever? Yes. Does it go up forever? Yes. So therefore, my range is also all real numbers. Cool. Okay, so moving on to our transformation, number 14. So our point here is opposite h, keep the k. So 2, -5. Now I know it's a line, my a is equal to 3, so my slope is 3 over 1. So I rise 3, run 1, and that's it. I'm done. It's just a line. Now, how did I get to my point? Well, I went right 2 and down 5. Right? Is my a value anything besides 1? It is. It's a lot bigger, so I stretched it. All right, so big, you're stretching those arms. Now, the nice thing, remember, our domain and range is going to be all reals because it's a line. Now coming back, we got to shift gears again because now I have the absolute value again. So my parent function is the absolute value. I still do the same idea. There's nothing inside the absolute value. So my h is 0 and my k comes after it, which is 4. So 1, 2, 3, 4. Now my a value is -3. So that a value gives me 2 different ideas now. Thanks to the negative, it's reflected. And thanks to the fact that it's a 3, it's stretched. And while I'm here, I'll just add our final thing. We didn't do anything left and right. We did end up having to go up 4. Okay. So what that tells me is from my vertex, I drop 3, and remember it goes to the right. 3 and 1. Reflect it over to the other side since it's absolute value. Good. Now your domain goes left and right, so it's all reals. Now range, this one's a little bit different. We just talked about it. You can pretty much, you know that it's going to be related to the y of your vertex. But now the tricky part is now that it's going down, so it's going less than 4. So it goes from here and down. So it's 4 and less. So it's going less than 4. Cool. We can do, I might skip the ACT prep. You can check that out in the notes. I'll do these last 2 super quick. Okay. So 16, pay attention. This is a line, right? Because we've got the parentheses. So my vertex is -1, 0, because there's nothing after. So -1, 0. And now my a value is equal to 1/2. So that's just my slope. So I rise 1, run 2. So that's it. The parent function is just x. Transformation is how do I get to this point? Well, I went to the left one. Is my a anything besides 1? It is. It's a half, so it's smaller, right? So it's compressed. And then our domain and range, easy peasy for a line. All real numbers. Now, believe it or not, number 17 is still going to be a line. So with absolute value, it has to have the bars. Okay, so this one you notice it doesn't have anything. So this looks like both. It looks like both HK form and MX plus B. Okay, and you're like, what? Seriously? If you look, if I go like this, right? So that's HK form. So we don't have. This should not say vertex. This one should say a point. Same thing for the other one. This one should say a point. Not a paint, a point. Okay, so the point is at, no, we don't have an h, and our k is -3. So 0, -3. Okay, and now my a value is equal to 1/4. Okay, so rise 1, go over 4. 1, 2, 3. Okay. So our transformations, how did you get to your point? I didn't have to go left or right, but I did have to go down 3. And then is my a something besides 1? Yes, it's smaller, so it's compressed. Cool. And then easy peasy on these guys since it's a line. Okay. Hope you enjoyed it. Talk to you later.